everyone. Last day we have discussed about the fundamentals of the chapter Similarity of Triangles, and three rules have been discussed. That is, one is SAS, AA rule and SAS rule. Three rules are SSS, triple S, triple A and SAS. So in triple A we have deduced that any two angles of a triangle are equal to the two angles of the other triangle. Then by mentioning AA rule, we can say that triangles are similar, because if two angles are equal, then third angle is bound to be equal. So these things have been already discussed during the last class. Today we will discuss the first theorem of the chapter. The first theorem is known as basic proportionality theorem, or it is given by Thales, so it is known as Thales theorem as well. Now this theorem states that, so first is the statement of the theorem. It states that if a line is drawn parallel to one side of a triangle, then it divides the other two sides in the same ratio or proportionally. What does it mean? In a given triangle, taken ABC and PQ, the line is drawn parallel to one side, that is BC. So this line, if a line is drawn parallel to one side, so PQ is drawn parallel to BC, then it states that it divides. It means that PQ line divides the remaining two sides, the other two sides, which are AB and AC, in the same ratio. So required to prove is AB by PB equal to AQ by QC. So given things are, so let us state all the steps and then we'll prove the theorem. Given is a triangle ABC in which PQ is parallel to BC. Now required to prove. So try to prove PP by PB is equal to AQ by QC. Now some constructions is already done. The constructions are, this line is already drawn PQ parallel to AC. Now from P we shall draw PN perpendicular to AC or AQ, they are the same line. And from Q we shall draw QN perpendicular to AP or AB. And join PC and PQ. So we have to write those things, construction. PM perpendicular to AC, QN perpendicular to AB, join PC and BQ. Now construction has been done. So how many steps are there in a theorem? You have to write first the statement of the theorem. If it is mentioned in your question or not, that doesn't matter. You have to write that statement. Thereafter, write the given things. Then to prove, and this is the third step. And construction, if in a theorem it is required, that is your fourth step. Generally, some constructions are to be done. And fifth step is the proof of the theorem. Now we shall consider area, ratio of area of triangle triangle APQ and PBQ. As we know that area of, since perpendiculars are drawn already, so we shall use half into base into height. So APQ, see APQ, this smaller triangle, we shall consider the altitude on the side AB. So AB will be taken as base, then on AB QN will be the perpendicular. So half into AP into QN. Now PBQ, see here, PBQ. If the base is taken as PB, then altitude on PB will be also QN, because this is the triangle PBQ. So if PB is the base, then opposite vertex is Q, and from Q on a line only one perpendicular can be drawn. Although this is obtuse angle, so we have to produce that side PB to draw the perpendicular from the opposite vertex Q. So if PB is the base, then QN is perpendicular. So QN gets cancelled, half gets cancelled, AP by PB. This is equation number 1. Similarly, we shall consider again area of triangle APQ. The numerator will remain the same, and instead of PBQ, from this side we shall consider triangle PCQ. Area of triangle PCQ, that is equal to, once again, half into base is APQ. Now instead of taking AP as the base in the first case, we shall consider AQ as the base, then perpendicular will be PM. So AQ into PM by half into PCQ. If you take QC as the base, then opposite vertex is P. So PM is the perpendicular on the produced CQ. So QC into PM. So PM gets cancelled, half gets cancelled, that is also equal to AQ by QC. This is equation number 2. Now see, these two equations 1 and 2, the left hand side of these two equations are, the numerators are same triangle, denominators are area of triangle PBQ and area of triangle PCQ. Now see the figures, PBQ this triangle and PCQ this triangle, they are equal in area because both of them are lying between the same parallels with the same base PQ. See here, PBQ. If you consider PQ as the base, then in PCQ, PQ is the base. So these two triangles are lying between the same parallels with the same base, therefore they are equal in area. So we have to state that here. Now, area of triangle PBQ equal to area of triangle PCQ. As they are why they are equal. Now if we see these two, left hand side of these two equations, numerators are same, denominators we have shown that they are equal in area, therefore LHS of these two equations are same. So from 1 and 2, if LHS of these two are same, RHS will be also same. Therefore write therefore from 1 and 2. AP by PP equal to AP by QC. So this is your result number say 3. So if the theorem is asked, then we have to prove up to this only, AP by PB. This is required to prove AP by PB equal to AQ by QC, which we have shown already. But two more results are there which will be used in course of solving the problem, and those results here I shall mention those two more results, and any one of these three can be used in course of solving the problem by stating it as a basic possibility theorem. The second one is obtained by just adding 1 on both the sides. So AP by PB plus 1 equal to AQ by QC plus 1. If you add what happens, PB is the base. Now take the LCM, PB as the LCM of the left hand side. Now this will be, numerator will be AP plus PB. See the figure, AP plus PB will be equal to AB. So this is your AB equal to QC. If you take the QC as the base, then AQ plus QC, AQ plus QC will be your AC. So that means if a line is drawn parallel to one side, then it divides according to a statement in the other two sides in the same ratio. So same ratio means this is one of the results. Second result is this, AB whole AB by PB equal to whole AC by QC. Means whole part will by this part AB, then whole part and this part QC. So this is second result, which is here only 4 because we have already mentioned equation number 1 and 2. So third result, fourth result. Now if you divide 3 by 4, what happens? PB gets cancelled, AP by AB. So also AP by AB equal to AQ by AC. This is 5 dividing 5. So, as per the theorem, if it is asked to prove, only write up to this step, but in your copy, write these two also, number 4 and 5, because they will be used as a result of the basic possibility theorem. Any one of the three can be used. That's all for this theorem. Stop. Now, second theorem is converse of the earlier theorem, that is basic universality theorem. So this states that the statement is in a triangle, this is the triangle ABC, in a triangle, if a line divides the two sides of the triangle, so these two sides are considered AB and AC. This line PQ divides AB and AC in the same ratio. That means it is already given that AP by PB equal to AQ by QC. Then the line is parallel to the third side. So third side is BC. Now we have to prove that PQ is parallel to BC. So first thing is given, you have to mention after the statement, so write given triangle ABC in which AC by PB equal to AQ by BC. This is already given. Now to prove converse means what? In earlier theorem, the line is given parallel and we have to prove that it divides the other two sides in the same ratio. But here it is already given that they are in the same ratio. This line divides the two sides in the same ratio. This is given and we have to prove that that line will be parallel to BC. So to prove is PQ parallel to BC. Now construction is currently we will write in the proof section. So write proof. If possible, because we have to prove that PQ is parallel to BC. If you take PQ is parallel to BC, then nothing is to prove. Now, if possible, we shall suppose that the opposite of it by method of contradiction that PQ is not parallel to BC. If possible, let PQ is not parallel to BC. So this is a sign of parallel. If you cut it by slash, it will represent that it is not parallel to BC. So if possible, let PQ is not parallel to BC. Then let us draw P are parallel to BC to P. So we have already supposed here that PQ is not parallel to BC. So this keeping this point P as fixed and we shall draw PR parallel to BC. Now as PR parallel to BC, so by basic proportionality theorem we can write therefore by this theorem we can write AP by PB as PR is parallel to BC, so AR by RC. But AP by PB equal to AQ by QC. This is already given. So from these two, call it equation number 1 and 2. Therefore, from 1 and 2, the left hand sides are equal, so right hand side should be also be equal. Therefore, from 1 and 2, AR by RC equal to AQ by QC. Now adding 1 on both the sides, this implies AR by RC plus 1 equal to AQ by QC plus 1. Now, as in previous theorem, taking RC as LCM and QC as LCM on the right hand side, So it will be AR plus RC by RC equal to AQ plus QC by QC. This implies, now see the figure, AR plus RC in AC by RC equal to AQ by QC. AQ by QC is again AC by QC. So AC gets cancelled. This implies QC equal to RC. So we have shown that QC equal to RC. What does it mean? That means Q and R are the same point. This implies Q and R are coincident point. Coincident point means they are the same point. So PR and PQ will coincide. Therefore, this implies PQ parallel. Now, we have already discussed about the second theorem. So, later on when we will be in the class, the live class, we will discuss it once again and we will show you if you have any difficulty. So that's all for today. Thank you very much.